Good morning students. Students, in this semester, that is 6th semester, we have to perform the practicals of a subject that is power electronics. This subject is basically very important and the practical of this subject is also very important because this subject is related to your GATE examination also. So being a power electronics subject, in this we have basically, we have to study the SCR. SCR is nothing but silicon control rectifier. It is also called as a thyristor. Now, when you are talking about SCR, it is having a thyristor family in which we have diac, triac, more of the things are there. That is SBS, SCS. So these things are there which creates the thyristor family. Now, talking about thyristor, the thyristor is which is used in companies or the industries for the switching as a switching purpose. It is also called as a switching device. Okay. So IGDP is also called as a switching device. So we have to study in today's experiment, that is experiment number 1, which is related to your VI characteristics of SCR. So first of all, let me tell you about the basic of SCR. SCR, as you know, that is called as a thyristor. It is having three, if you see the symbol, it is having a three things, that is anode, then gate, then K, that is cathode. See, when you are talking about gate, in this particular thyristor, if you see the difference between thyristor and diode, the diode consists of anode and cathode like this. So it becomes a forward bias and reverse bias. But in case of a thyristor, we are having a gate terminal, and this gate terminal, with the help of this gate current, you can say, it will trigger in the sense you will on the SCR. Okay, so this is your circuit diagram for the today's experiment, that in which you have to draw the VR characteristics. Matlab, you have to just calculation. If you see the calculation part, you have to calculate or you have to see the voltage and the variation of voltage and current. Okay, so this is the voltmeter V, the voltage is given, and this is the ammeter in which we are having a current. So first of all, I want to tell you some theory regarding the thyristor. So this is the diagram where you can see there are the three junctions. Okay, so J1, J2, J3, and the three terminals A, K, and G. Okay, now when you are talking about the anode voltage, so this is your anode. So when this voltage is made positive, if you are having, this is a positive voltage with respect to the cathode, that means this is negative. Okay, then at that time your VG, that is the gate voltage, is 0. Okay, VGK, your gate to cathode voltage is 0. Now in this time your J1 and J3 will be forward biased. Okay, J1 and J3 will be forward biased, and this J2 will be the reverse biased. Okay, from this we can say only the small leakage current flows from positive to negative. When you are saying J1 and J3 will be the forward bias and J2 will be the reverse bias, at this condition a small amount of leakage current flows from positive to negative. The thyristor is then said to be the forward blocking or off state condition. This is called as forward blocking or off state condition. Okay, now at that time there is a leakage current, and this is called as a ID, or that is called as a off state current, that is ID. Okay, now this anode to cathode voltage VAK is increased. Okay, so this is the theory part. When you have to increase the anode or to cathode current, that is VAK, which will be increased in a sufficiently large value, that time the J2 will be reverse biased, and due to this reverse bias the particular characteristics goes to the avalanche breakdown. मतलब वो वहाँ पर breakdown होगा, that means like this, the avalanche breakdown is like this in case of a reverse bias. Okay, so now see the circuit diagram. This is our circuit diagram. This is VG. Okay, now this is RG. This VG is nothing but the voltage across the gate. Then this is RG, gate resistance. So this is connected to G terminal. Now this is your SCR. With the help of this SCR, we are having a voltmeter in a parallel to the SCR for measuring the voltage. Then we are having a resistance and one ammeter which measures the current, that is called as a anode current. And this is your output voltage, or you can say VAK, that is anode cathode voltage. Now come towards the circuit part. Now see, first of all you have to just see what is required in this experiment. So this is one trainer kit. Okay, in which this is the circuit of SCR. for drawing the SCR characteristics. This is voltmeter and this is ammeter. So these two knobs are there where we have to increase your gate current, because for turning on the SCR we require the gate pulse. Okay, so triggering the SCR as you studied in the theory also. Now this is a power supply knob. We have to adjust the VAK voltage. Okay, now start the experiment. Just you have to increase the voltage where your current is 0. So suppose, now see, you have to gradually increase the voltage. If you see the voltage, if I am increasing the voltage, then also your current, this is the anode voltage and this is the anode current, that is the leakage current. Okay, so when you are gradually increasing the voltage, then also the current is your 0, because when you are saying the voltage is increases but the current is 0, at this state your particular SCR is in off state. Okay, so at 12 volt, suppose some amount is fixed here, it is a 12 volt. After 12 volt, the current will be increased. Now see here, gradually I am increasing. Now we are having 12. Okay. So approximately we are having a 12 volt. So this is supposed to be a 12.1 volt. So what about the reading? You have to take reading in this manner. So this is serial number 1, then VAK, then IAK. If you see according to the reading, that is VAK, when it is 1, again the current will be 0. Up to 12 you can say, up to 12 the current is 0. But after 12 you have to give the gate voltage. And when you are turn on the gate voltage like this, you just see the changes. You just see the changes, the current will be there. Just see the change, the current will be there. So this will be the exact reading that you have to take down, because there is an avalanche breakdown in case of a third quadrant. Okay, so in this manner you can understand when you are increasing or when you are giving a voltage to the gate, okay, VGK, when you are increasing VGK, at that time your anode voltage will be less. अब मेन चीज आते हैं अपन, दैट इज कॉल्ड एज कंडक्शन टाइम. कंडक्शन पीरियड में क्या होता है, देयर इज अ टू करंट, वन इज लैचिंग करंट, अनदर इज अ होल्डिंग करंट. सो लैचिंग करंट इज दैट करंट at which it is a minimum amount of current where the anode current is required to turn on the SCR, okay, at the blocking state. But holding current is that current, it is a minimum amount of current, obviously it is an anode current to required to maintain the SCR in the on state. Okay, so this is the two currents which is required in the characteristics. So when you are giving the voltage at to the gate, then this voltage, anode voltage, is decreased. Okay, it is up to 0.07 and now the current will be increased. That is called as the conduction. This is the conduction. Now you are increasing the voltage, so your current is also increases. But your voltage is 0.07 but current is increasing. So that means this voltage is constant, that is anode voltage is constant, but your current, that is leakage current, that is gradually increasing now. So these are the readings that you have to take. Here see, your current is increasing but your voltage is constant, that is 0.7. So in this way you have to perform the experiment of SCR VI characteristics. So now lastly we have to see the characteristics, that is the main part of this experiment. Now see, this is the characteristics. So in these characteristics, as you see here, we are increasing, now we are applying the gate current. So these are the different types of gate current, IG1, IG2, IG3. So IG3 will be greater than IG2, IG2 will be greater than IG1. ये चीज आपने theory में भी पढ़े हैं. So this particular point, at this particular point we can say the SCR is conducted. So this is called as a conduction mode, or you can say this is called as a forward conduction on state, where this point is nothing but, before that I want to tell you one thing. In x-axis there is a V and in y-axis there is I. So when you are talking about your this current will be here. Now see, there is a voltage VB0. This is called as forward breakover voltage, that is forward breakover voltage. When you see in the reverse side, then it is called as a reverse breakover voltage. At this point, as I already told you, there is an avalanche breakdown, and due to the avalanche breakdown, this particular graph, or you can say this particular characteristic, will go down. So this is called as an avalanche breakdown, and this is nothing but your VI characteristics. So now we completed your first experiment, that is VI characteristics of SCR. Thank you.